Hopefully for this problem, you're seeing some similarities to the first example. Yeah, it's got a fraction, but I'm seeing sine squareds and cosine squareds. I'm also seeing a lot of stuff going on, and so I'm wondering, can I factor? Can I possibly cancel? Somewhere can I use a Pythagorean identity? Alright, let's take a look. Let's just start with the numerator. Actually, let me address something quickly. Some of you might be thinking, hey, look, we've got sine t in the numerator, sine t in the denominator. Let's just cancel these out. It would be nice, but we actually can't here. The reason being, we're not multiplying. We can only cancel in fractions when we're multiplying, so that method's not going to work. Let's look at the numerator, though. You notice a sine squared term, you notice a sine term. You may or may not see this, but this is similar to a problem we did in the factoring review. Remember when we took 2x squared plus x minus 3? And then we factored it. We broke that into 2x times x, and I think it was plus 3 minus 1. Check it. Yes. Alright. We can actually do the same thing with sines. Do you see a sine squared and a sine? I'm going to go ahead and I'm going to factor that numerator. I get 2 sine of t, see that? Times the sine of t. If I was going to FOIL this out, I'd take this times this, and I would get 2 sine squared of t. Then I'm going to put the plus 3 minus 1 in. It's a little bit easier because we've already done it with just x terms. And if you want, you can do that on your own as well. But you'll see here this gives us the minus 3 that we need. And we check our middle term. We see we get 3 sine of t minus 2 sine of t, which is going to give me the middle term I need up here. Okay, that's the numerator. Now, for now, I'm just going to write the denominator in 1 minus cosine squared of t minus sine of t. Now, we've got a cosine squared. If you think back to our Pythagorean identity, you might say, hey, couldn't we do something with this? I mean, if cosine squared theta plus sine squared theta equals 1, I could rearrange this a little bit. I could get cosine squared theta equals 1 minus sine squared theta, and maybe I could replace this in the equation with this. That'd be a great idea. You could. I also want to rearrange this a second way. So another way to rearrange cosine squared theta plus sine squared theta equals 1. Instead of subtracting the sine over, let's subtract the cosine squared. That's going to end up with sine squared theta equals 1 minus cosine squared. Now, if you look back at our problem, notice something? Pretty cool, huh? We can replace this with sine squared. So that's exactly what I'm going to do. Alright, for now I'm going to rewrite the numerator. Divide by the denominator, but now in place of 1 minus cosine squared, I'm going to write sine squared of t minus sine t. Now some of you are thinking, come on, Prof. Rassi, I would never have done that. I would have never thought to do that. And right now you're right. But as we get through the unit, you'll get more comfortable with it. You'll probably even have a list of all the identities that you can use, and you'll start to recognize tricks like that. One other thought, if you would have replaced it with cosine squared theta with this, you would have ended up with the same result in the end. This just saves you a step. Alright, but you might be looking at that and think, well, great, this doesn't look any simpler than what we started with. And you're right, it doesn't. It's not. But we're still working with it, and we're hoping something cancels out. If nothing cancels out, then we got to start over. We got to go back to the beginning, try something else. Alright, let's take a look at that denominator. What do you notice? Do you see a sine squared t minus a sine t? Do you see a common factor in both terms? Hey, this is really good. Can you see why? I'm going to rewrite the numerator. But you see I can factor out a common factor of sine t? When I take sine t out of here, I'm left with sine t. And sine t divided by sine t just gives me minus 1. Hey, 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 that's good, right? We can cancel these. And my final answer then is 2 sine t plus 3 over sine t. Now you might think after all that work we're finished. It would be nice. But we actually can take this a step further. Remember when I asked you to consider the two fractions and how we could break them up? We can break this one up a bit further. If I break the fraction up, again, this is kind of the reverse adding of fractions. I have common denominators, I put them together and get a new fraction with only the single denominator. Here I'm just going backwards. Why is this good? This is a question you want to ask yourself as you're doing these problems. Is this helping me, and why is this helping me? In this case, you'll see the signs cancel. And I'm left with 2 plus... Some of you are probably looking at that and thinking, hey, that's cosecant. Others of you are thinking, cosecant? What's going on? So I'll break this into 2 steps. Would you agree that I could break that apart like this? And now are you seeing cosecant? We know that 1 over sine t is the reciprocal of cosecant. So, my final answer here, I get 2 plus 3 cosecant of t. And even though this was a lot of work, you have to admit, that's a lot nicer than what we started with clear up here at the beginning.